Okay, I'd like to continue same file about how to design the column. So there's no difference between the column design over to Canvas and then over to imported building plan. So right now we have imported the house plan, and then this case we like to design the column and foundation. So first things is you need to go to column module. So there are two different things. One is just the solid so the single column or the multiple column, and the other one start wall design. And for this example, I'd like to show just the column design. Click this one here, and then we're going to uh, put our columns right this way. Then it show, make I zoom it to a little bit bigger. And then, so same idea, we can change the name, just HOL1 here. And length, maybe we can change about 8 feet is enough for this case, maybe 7.5 is enough. No, it's the, yeah, okay, yes. Then is all the adjustment factor. Uh, well, I like to use default 0 right now. And then go to designing. Since this is going to be top view, so that we cannot show the column side view in this canvas here. So we provide, the program provide, is called the ServGI systems here. So you see the column design, and right now we have only the actual force going on. So then you can click this one here. It open up all the loading condition here, and then we expect, I mean this one is a dead load. This is a total force 650. So that you might expect this one about I mean we can get the more accurate the reaction, but it's for this situation, I just guess that is about 200 is dead load, and the live load is about 500, right this way. And then also this is going to be hinge top and bottom, but of course you can manipulate fixed different loading the fixed conditions. And then you can apply the what do you call this, the eccentricity, and maybe this case is here is a v.5 here. Then since we don't have any actual force, and we don't need point load here, but it's in case, I mean let to show what's going on. Just open up this one here, then you can apply add, and then you can maybe so the, okay, let me show this one here, designing some pictures, actual force, and if you have point loaded there, add here, automatically show like this way, right? But since we don't have any actual force, I mean the side force here, just remove it and close it here. And distributed load, also same idea, we don't have any side here, this one, so that we're not going to, so we don't have this one, let's remove this one. So basically this is done, and then we have to choose member, so that for this case typically we like to use the solid sun, and then open up, close this one here, open up this, and then we're going to use maybe number one, and then this is typically we're going to do 4x4 members, close this one here. Then you just go to calculation, click this. Yeah. So this one is the same idea, show the all the informations, and then number one is um, actual force going on only here, and there's a little bit of the side force because of eccentricity, but it's anyway actual force probably is most control here, and so that number one is 4 by 4 dead or alive is adequate. So just accept this button here, and then it show, see this one here, same things as we done in the beam design. So that this case we just crowd it here, so you may manipulate where you're going to put it. So that case we just you can moving around. It's just hold it a little bit difficult, but anyway, this is a way you can control. Also, you can size the column, the shapes here, right this way, so any place you can put it. And then same things, and then if that case, for example, like the other case here, like for example, we have several beams here. For example, inside we have for example, we have several 2 by 4 members, some place like this way. Then it's the same idea. Go to column here, and then draw the here, and then go to maybe column 2, length is about 7.5, and then default is okay right now. Actual force you can apply maybe about typically that happens about 3,000, and the live load maybe about 6,000. That is a typical numbers for the actual force there. And then is go to visual, the solid zone, and then typically there's stud. You choose stud there, remove this one, and then we like to have members, maybe 2 or 3, right this way. Then do calculation. So in that case, of course, we 4 by 4 members, and then dead load and dead thrust live here. And then you see this one 2 by 4 members still not adequate right now. So in that case, we may increase maybe size case here, so that we can do as you need it, like this way. Yeah, so 2 by 6 is fine, and then probably 2 members is still okay. So the double 2 by 6 is okay too. So we accept this one here. That can show like this way, 2 by 6 member. So basically we done the column design. Like this is very similar concept as you done in the beam design.